Hi, my name is Joel Matthew, UR15CS177, and today I am going to be explaining my fourth experiment from networking lab. So the concept we are using is static routing. This is actually our network. Static routing is actually a form of routing in which we have to manually configure the router to find the route to the given network. So this is our given network. So as you can see, we have 5 routers which are connected to in a serial fashion, and we have a LAN connected to this router, another one here, and one here. So as you can see, total we have 4 LAN networks, and actually these interconnected routers form a WAN network. So this is a WAN, this is a WAN, this is one, and this is one. So total we have 4 LAN networks and 4 WAN networks. So the network IP which is given to us is actually 192.168.1.0 with subnet of 24. So we have to use this IP uh, which this IP is you going to be used to actually form the IP for each of these networks. So we are going to be using the concept of subnetting. So we need, since there are 8 networks, we need at least 8 subnets. So in that case, we'll have, for each subnet we'll have 32 IP addresses, one for network and one for broadcast, and total 30 usable usable host addresses. So first, for this one, the network IP is actually 192.168.1.0 for this network, and this one has from 32. The network is 32, and here it is. Sorry, this is 32. This is 64 dot 1.64. This is 1.128, and so on. So to actually so we have actually assigned the required addresses for each of these. So to as you can see, this router is actually connected to this LAN network and this WAN network. So it has the network IPs for both of these networks, but it does not know the network IP for this LAN, this LAN, this WAN, and all these other networks. So the routing table of this router will not contain all these the network IPs of all these networks. So we have to actually manually configure the router to get this information inside the routing table. So for this we have to go to the command line interface of the router, and we have to go in. Let's first just exit, and we have to go into the privilege mode, and then we have to go into the global configuration mode, and after this we have to actually enter the command called IP route, and then we have to enter the network address or destination IP network. So let's enter 192.168.1.32, and then we have to enter the subnet mask. So this is the subnet mask 255.255.255.224, and then we have to find and either we have to enter the next hop IP or an exit port. So let's enter the exit port as serial 2/0. So as you can see, this information is actually goes into the routing table. So I have already I've already I've already prepared this whole network, and we can see this using this static. So in this we can see all the routing configurations. So let's just see the routing table once. So as you can see here, the connected networks LAN 1 and LAN, which is LAN A and WAN A are connected, so these are shown by C, and S means these are serially connected, so it has the information for all these other networks. I have done the same thing similarly for each of these router using the same command. Uh, there's one more thing we can actually control that. We can actually see the IP, the routing table using this command, show IP route. So this will again show all the connected networks to this router. So let's try once pinging this device and this device. So let's just once see the, okay, 97. So let's see if our routing is correct. So let's try pinging. So 192.168.1.97. So the packet is being prepared. So we are only seeing for ICMP protocol, and we are going to ping this device to PC7. So let's see how, if our routing is correct. So as you can see, the packet has gone to, the request has been sent from PC0 to PC7, and we get back the reply from PC7, and which goes back to PC0. So this shows that our the static routing which we have done is correct. So I hope this video was helpful for you. Thank you for listening to me.